Hi, I'm Mr. Franklin. In this video, we're going to do a quick comparison of parallel circuits and series circuits. So down here at the bottom, I'm going to build this series circuit. And up here at the top, we're going to build a parallel. The secret to remembering which one is which, a series basically means that the current has only one path that is going to follow, whereas parallel, it has multiple paths that it's going to follow. So right now, I've got a battery, a switch, and a light bulb. Battery, switch, light bulb. And notice that the light bulbs are the same brightness because we have the same battery. We have the same type of light bulb. So let's go to our series circuit and we're going to add a light bulb in series. So let's add a light bulb. So now we have two light bulbs in series. Now notice that both of these light bulbs are slightly less bright than the individual light bulb. And if I add a third light bulb here, they're even less bright, but notice that they're, because they're the same kind of light bulb, they're the same brightness. Go ahead and complete our 4 light bulbs so they're even less bright. Let's take a look at parallel. So I've set this up with a switch, so I'm going to turn on the next switch and notice the current is following this path. Then it's going to divide, it's going to split. But notice both light bulbs are bright, the same brightness. In fact, this one did not change its brightness. I add another light bulb and then I add a 4th light bulb. If we actually measure the voltage across each one of these, what we're going to notice, we got a 10-volt battery. So the voltage drop across this should be 10 volts. Voltage drop across this is going to be 10 volts, 10 volts, 10 volts. Whereas if I go to series, it's going to be 2.5 volts. Do the next one, it should be 2.5 volts, 2.5 volts. And what's going to happen basically is if you add up all of the voltages for all of those light bulbs, it will equal a total of 10 volts. So in a parallel circuit, each component gets to draw on the full push available. It gets the same push for each component. Whereas this one, it gets the same push, but the push is at a smaller amount for each component. So let's take a look at the current. So the current here is 2.6, 2.6, 0.67, 0.67, 0.67, 0.67, 1.33, 2.0. So you can see that the current is different in different parts of this circuit. Whereas if we look at this, 0.17, 0.17. What you're going to notice with the series circuit is the current is the same throughout. Here are the big important things to understand. You've got parallel you get all of the voltage for each component, but you're going to have different currents throughout the circuit. This one, the current's going to be the same, but each piece is going to get a different byte of volt. So now your question that you're going to answer in the Pear Deck is, why might that be important? Because parallel is how your house is generally wired. Now there's parts of it, like from the transmission line to your house is actually wired in series. But why might it be important to wire things in parallel based on this idea? And then why might it be important to wire it in series based on this idea? Go ahead and put that in the Pear Deck. Okay, here is your second question. Here is another reason why parallel or series might be important. Because what happens if something happens to my circuit? If I, for example, cut the wire or break that part of the circuit, notice what happens. These two pieces of the circuit continue working. But watch what happens here if I break this part of the circuit. One part of the circuit, the whole circuit dies. Whereas if I break one part of the circuit, only a few pieces fail. So why might that be important? Put that as your next question in the Pear Deck. Cool. I look forward to seeing your answers and we'll discuss those in class. Thank you for watching and have a great day.